Hi, and welcome to the series on FreeRTOS with ESP32. In this, we are going to go ahead and understand what exactly is FreeRTOS, how is it different from the general operating system, and what is an RTOS and how is FreeRTOS making the things much better. And what are the different reasons like we go ahead and then choose the FreeRTOS for our projects and so on. We'll also understand like why is this FreeRTOS so popular in comparison to many others what we have out there. Further going ahead, we'll also see the different features and the salient things with FreeRTOS, where I'll try to give you an analogy for understanding like what exactly happens. We'll also try to understand the same thing with an example of the conventional way of executing the programs and the FreeRTOS and how exactly they make it easier for us to get it done. Let's get into it. Alright, so let's get into it. What is a general purpose operating system? So any operating system is nothing but a program that helps a computer to go ahead and provide some basic functions, handle the hardware, the low-level functions and all of these things so that the computer keeps on running. So this is a general purpose operating system out there, right? Let's understand the RTOS now. So RTOS stands for real-time operating system. So these are nothing but an operating systems for real-time applications or real-time devices. In other words, these are for those things or a process where the time is very critically defined and so on. That is, it has to execute something. For example, emergency systems, emergency response systems, the fire alarm systems where the time is very, very constrained. In such scenarios, we use a RTOS, that is a real-time operating system. So one of the real-time operating system is your FreeRTOS. So FreeRTOS is a pretty much popular out there, which has been used for a long time out here. So it's a class of real-time operating system which is designed to be small enough so that it can run on microcontrollers and so on. Although it's not just limited to microcontrollers, but yeah, it is much more widely used in the microcontrollers. So now let's understand like why exactly do we need this FreeRTOS or real-time operating system. Let's take a quick example out here. So when you go ahead and blink an LED, what happens? A normal way we do it, like we may have multiple different tasks and then we run those in a single microcontroller. We are not really able to make out like which is executing at what time and everything seems to be working properly fine, right? So you don't really get to know like what is the difference between all of those different things out here. But what is the things? So here is a quick understanding here. A normal setup, a normal program works like you have an entry point, that is your setup function, and then you have a loop function where you have defined some sort of functions or you have some set of executions to be happening. So they execute one by one and then again keep back to the looping. For example, you have made the turn on LED 1 and turn on LED 2, turn on the motor, serial print, and then fetch some information, print that information, and then it goes back again here. What's happening is it is looping, it is constantly looping. So it's kind of like a super loop, it keeps looping forever and ever. So the thing, all the tasks what you have inside it keeps getting it. But they're not running simultaneously. What do I mean with this is like, here's a quick understanding here. On the first here, you see this, these are running simultaneously. With respect to time, all the three functions are running at the same time. That is, you have these tasks being executed at the same time, which is known as multitasking. Whereas on the other hand, we have a concurrency, which means that any one single task is being running at a time, and the time is being scheduled or time is being sliced to every single task or every single process in a given interval of time. So first, task 1 executes, then it gets suspended, then task 2 executes, and then it gets suspended, then task 3 executes, it gets suspended. Again, the same thing repeats. And this happens in a very fast cycles. Usually we don't give a delay, right? So it executes pretty much fast, and it seems to be like they are all running together. They're all running simultaneously, but they're not really running simultaneously. They are running only one task at a time. And here we go. We have three tasks running simultaneously at the same time. So this is what is multitasking, and this really becomes very much important whenever we have some critical things to be constantly been running, and like they need to be really running in the like simultaneously at the same time. That's where we need a FreeRTOS. Now here comes one important point. Can we do this FreeRTOS in case of your single core processor? Because we know that a single core can run only one single task at any given point of time. That's how the CPUs function. That's how the microcontrollers function. That is, they can only execute any one single process or any one single instructions at the same time. So can we still run this FreeRTOS into them? Yes, we can do that. But the thing is that will work this way. That is, you will have a concurrency. That is, they will go ahead and work this thing. And that's the reason FreeRTOS is pretty much good for those which has a dual core or multiple cores microcontrollers and so on. For example, you have an ESP32 which has a multi-core processor. So core 1 can run one task and core 2 can run one task. So these two tasks can work simultaneously at the same time. So that's how they become pretty much good to go ahead. I hope it's very much clear like how exactly the multitasking versus the concurrency and why do we exactly require a FreeRTOS in simple. Let's go ahead and understand like why FreeRTOS. So you see this like the stats here. FreeRTOS has been according to the E Times Embedded Market Study 2019. FreeRTOS is having a very large market share. And also we just have a look at these things like IoT operating systems. Even here you have a FreeRTOS covering up 20.4% of the market, which is really good. FreeRTOS is owned by Amazon, which then makes it a lot much of a value and a lot much of a good community to work on it. So alright, so let's go ahead and understand like what are the different features which has been provided to you by the FreeRTOS, and here are the some which I have mentioned out here. The very first thing we have with us is like abstract out timing information. What exactly does this mean? So FreeRTOS separates timing information from your code, making that your application code is easier to understand and maintain. So in other words, a real-time scheduler allows you to go ahead and then specify timing characteristics of your application. Let me give you a quick understanding to make it easier for you. Imagine that you have you're baking a cake. So FreeRTOS separates the timing information, like how long the cake should be baked from the actual recipe itself. So this makes the recipe easier to understand and follow, and you can go ahead and then change the baking time without affecting the rest of the recipe and so on. So I hope it gives you a quick idea like what exactly it means to be removing the timing information or abstracting the timing information from the code out there. The second thing is maintaining an extensibility. So having a time information outside of your code leads to a fewer independence between the software modules. Or in other words, you can say like changing one module will never affect the temporal behavior of the other modules and so on. So let me give you a quick analogy to understand this one also. So let us say think of a car which each part is separate and modular. So if one part needs to be replaced, what happens is like you need not to go ahead and do anything else. Like it can be done without affecting the other ones, rest of the car. So the FreeRTOS works the same way, where each software module is separate and can be updated, affecting the rest of the program up there. The third thing is modularity. Modularity is nothing but organizing your application as an autonomous task, leading to the more effective productivity, where the task should be loosely coupled and functionally cohesive units that executes on a sequential manner. In other words, if I have to give you an analogy to understand this thing, let us understand this way. So in a factory, each worker is assigned a specific task, like assembling a specific part and so on. This leads to be more organized and efficient production in line. FreeRTOS does the same thing. What it does is it goes ahead and organizes the program in a similar way, where each task is assigned as a specific job, making the program easier to understand and more efficient. The fourth point is FreeRTOS also helps you in cleaner interfaces. What does it mean? It means that you will have a well-defined inter-task communication interfaces, facilitating the design and team development. Let us understand this with the example of analogy out here. So imagine a team working on a project. If each team member know what they need to do and how to communicate with each other, the project will be completed faster and more efficient. FreeRTOS provides a clear communication channels between the software modules, making it easier to work together and complete the project faster. Testing softwares can be difficult because it can interfere with how the program actually works. Imagine a doctor examining a patient without causing any pain or discomfort. FreeRTOS provides a way to test software without affecting how it works, which makes it a lot much easier. The sixth benefit is code reuse. Great modularity and less module dependencies facilitates code reuse and across the projects. Tasks themselves facilitate code reuse within a project. Imagine building each room where it has a specific purpose, like bedroom or a kitchen, or the building needs to be expanded. New rooms can be added without affecting the rest of the house. The FreeRTOS organizes in a similar way. Each task has a specific purpose, making it easier to add new tasks without affecting the rest of the program. 7. Improved efficiency. So there are various different things which makes the FreeRTOS, and one among them is improved efficiency. Using the FreeRTOS permits the task to block an event, meaning no time is wasted in polling or checking timers. This can result in huge saving in process utilization. Code only executes when it needs to be. Let us take this in a simple way and understand what is this. Imagine a teacher giving each student a specific task like cleaning the blackboard or passing out papers. This makes the classroom more efficient because each student knows what they need to do and how to do it and when to do it. FreeRTOS works the same way, where each task has a specific purpose and only runs when it needs to be, making the program run more efficiently and more better. Benefit number 8, idle time. The idle task is easy to measure processor loading and provides a simple and automatic method of placing the processor into low power mode. In other words, whenever there is no reuse of it, imagine a computer that goes into sleep mode whenever it is not being used, saving energy and extending the battery life. The FreeRTOS provides a way for the processor to get into the low power mode when it is not being used, saving energy and extending the battery life of devices that uses it. Benefit number 9, flexible interrupt handling. Imagine a traffic signal that can change the timing based on the amount of traffic on the road. Similar way, the FreeRTOS works similarly, where it can prioritize different tasks based on their importance and urgency, which makes it easier for us to go and handle the important tasks first. Then we have mixed processing requirements. Imagine a restaurant serves both fast food and gourmet meals. They have separate kitchens for each, making it easier to manage both types of meals. The FreeRTOS allows you to manage different types of tasks in a similar way, making it easier to manage both the periodic, event-driven processings and so on. Finally, easy control over peripherals. Imagine a security system that needs to be managed multiple doors and locks. FreeRTOS provides a way to manage these peripherals, making sure that only one person can access a door at a time, ensuring the system is secure and so on. So these are the few quick benefits of FreeRTOS. Let me go ahead and know if you really love this FreeRTOS and want to explore this out. We're going to come up with various different projects into this and check out this one by one. I'll see you in the next one. Thanks for watching.